Okay, today's topic would be association mapping, one-to-many bidirectional. Okay, and one more topic I'll be covering today: association mapping, many-to-one bidirectional. So these are the two topics I'll be covering today. Okay, so see, before I start the class, one thing I would like to tell. What means? By the end of the class, you'll understand both are same. Many-to-one bidirectional also is same, as well as one-to-many bidirectional is also same. That you'll understand by the end of the class. Clear? So anyway, just I gave you the information about it now. So we'll study them separately. Then by the end of the class, the summary will be done. And one more thing is, see, this is the most important example what you're seeing, and extensively used mapping in your companies and all your projects. Extensively used. So this bidirectional mapping is the most important one. Clear? Okay, you can note it down. V to the power of 101 times important. This example. Okay, fine. So now let's start off these two concepts now. So the two concepts what we'll be covering is one-to-many bidirectional and many-to-one bidirectional. So we'll start off now first with association mapping, one-to-many bidirectional. We'll go with this now. So first, the word association mapping. So when do you do association mapping? When there has a relationship. So we are just understanding all the terminologies now. Association mapping is generally done when there has a relationship. Like example, department has an employee, employee has a department. It's an example, correct? For so when you're having has a relationship, that is when you go for doing association mapping. See, again one more I'll give. Student has an address, address has a student. Again what? If you're having has a relationship, then you'll go for doing association mapping. Then next, association mapping you understood. Now what is one-to-many? That is cardinality. Means number of occurrences. Okay, so one department can have many employee. That is cardinality. Okay, and there you can see many-to-one. Many students are having one address. Means many students are staying in one hostel or PG, something like that. So that is cardinality, number of occurrences. So we are clear with these two terminologies. Which one? Association mapping we have understood. From past a few examples we have understood that one. And one more thing what we have understood is cardinality. Both we have understood. Direction also we have understood. But we have understood unidirection. So today's main concentration is direction only I will be focusing. But only we will be discussing bidirection. So rest all is being covered for you. Which one? Association mapping you know. Cardinality you know. Only we have to focus on direction today. So instead of unidirection we are going with bidirection. That is all the concept today. So it's going to be very simple, but to understand this you should know the previous example of what? Many-to-one also as well as one-to-many also. If you know those two, now this will be a very simple thing now. So first I'll be going with the example. Now I understood the concept, introduction again. So I'll be going with an example now for what? Association mapping, one-to-many bidirectional. I'll be going with this example now. Yes, to understand that, yes, the example I would take is one department has many employees. That's the example. So one department has many employees means what? See this table now. So concentrate on this diagram, leave that diagram now. Yeah. So which one? We are going with one-to-many, means one department has many employees. Fine, let's look at the table now. So we are having in this department table two columns are there, department ID and D name. These are the two columns. In employee table there are four columns, EMP ID, E name, email and department ID. So fine. Now again in department table, these are the two columns. In these two columns you can see department ID is the primary key. Fine. And in employee table, EMP ID is the primary key. We are having one more department ID which is the foreign key. Foreign key means what? Yeah, this is referencing the primary key of department table. This department ID is referencing the primary key of department table. So this is the design of our table now. And in these tables I have filled the test data. What test data? See here, test data. Department ID number 1 and there is a department by name IT. And in this department 3 employees are working. Who are the 3 employees? Tom, John and Peter. They are working for department number 1. So that's what we are saying. One department has many employees. Then one more department is there, sales. Again there are 2 employees working for it. Who? James and one more is Bond. So fine. So you can see now these 2 employees are working for department number 2, that is sales department. So that clearly shows that one department has many employees. Okay, fine. So now for these tables now, okay, see these are the design of the tables and you have understood all this. Now I give you some scenario. First understand the scenario, clear? Then we'll come to how we design the entities. Scenario is very simple. See, the user you might ask the user to enter. You'll ask the user to enter department ID. Means you'll ask the user to enter the department ID now. Enter the department ID, and you'll have one field here, and he'll submit it. So once he enters that value, you're supposed to, your application, you have to write the code. You have to connect to the database, fetch all the values, and display all the employees working for what? That particular department. Supposingly enters 1. So you have to display what? All the employees working for department number 1. Means who are they? Employees are, you have to write some message you give. Employees working for department number 1 are Tom, John, Peter. You have to display like this. This is one scenario. Now one more scenario I'll give you now. Okay. We are going to enter the employee ID. This is another scenario. Okay. So if I enter the employee ID, I want his department now. I want his department also. So if I want the department, yes, you will enter the employee ID as what? Supposingly 2. But the display what you should get is what? This employee is working for department number. Employee belongs to whatever. Employee is working for which department? Employee number 2 is working for department ID 1 means IT department. So this is our requirement in the project now. So these are the two tables. And definitely you'll get this requirement. Enter the employee ID, you should get the department, and definitely other way around. When you enter the department, you want is all the employees working for that particular department. So this will be the scenario. So that is why this example becomes very, very, very important. This is the extensively used mapping now. So concentrate now. You have understood the tables. You have understood the scenario. Now we'll see how we will design the entities or a TO. Yes. Now when I give this requirement, end of the day what will you do? You'll write the code. You'll write the code to connect to database, fetch the values, and those values will fill into what? The TO or entity. That's all you're going to do. So let's understand how we are going to design the entities or TO now. This is the requirement I given to you now. So you have to write the code to fill the values to connect to database, get all the values from the database and transfer it into the TO now. And this TO you will carry it to the view layer and display all the values. That's how you'll be coding your project. So you should understand now how you will design your entity or TO, which is very, very, very crucial. And this becomes very important because all the data from the secondary memory will fill it into a TO or entity itself. Yes. So very clear with this. Having understood the tables, having understood the scenario, now we'll go into the design of the tables. So, design of the entities. So we are having one entity by name department here and one more entity means Java classes. Okay, we are having called as employee. So in the employee, see I'm having 3 properties: empid, string ename, string email. So these are the 3 properties, and these 3 properties will be mapped with these 3 columns now: empid, ename and email. That is very simple. Similarly this side, if you see, we are having department ID, dname. These 2 properties will be mapped with these 2 columns, which are department ID and dname. Everything is done. So now what we have to understand here is, now in the department we are having set of employees. That's one extra property what we are having here. And here means we have to understand. And in the employee entity we have to understand one more property called as department. So what is department now? Department is a variable of type department. Department is a variable of type department. Here what is this? Employees is a variable of type set. And we are using generics here. This set will hold only employee objects. Only employee objects it will hold. We are using generics. So these are the 2 properties what we have to clearly understand now. Yes. So now let's clearly understand one point here before we move to the entities. Again, see in the relational world, we relate the tables using ID, that is primary key and foreign key. That is one thing you should clearly understand. Next point, in the relational world what happens, or in database, see in the database the tables are bidirectional. Bidirectional means what? Understand this point now clearly. If I give you a value from the parent table, this is the parent table now. If I give you a value from the parent table, you can navigate to the child table and fetch the records. Means you will do the join and you will get the records. Similarly, if I give a value in child table, I can navigate to the parent table and get this record. Means, see, if I give you some value in the parent table like IT, okay, and if I ask you to write a query to get the values who are working in IT department, you'll write the query, you'll write on join and you'll get the values. Means if I give a value from this table, you can fetch the records from child table. Similarly, I'll give an email or name and I'll ask you find out this person works for which department. You'll write the query and you can get the values from the parent table also. So in the database, the tables are bidirectional. Bidirectional means you can navigate from parent to child as well as from child to parent. Understood? So, and their terminology is only different. Like we relate the tables with ID, primary key, foreign key and all that. Fine. Now the same concept, we want to do it in Java. But the world is different now. We are talking about what? Object-oriented world. This is not relational, this is different, relational world. But we are talking about a object-oriented world. And here, we talk in the terminologies of what? Object, reference, like that. So that is why, see, clearly understand the point now. Department has many employees. So I'll go with what? Has a relationship. This is object-oriented world now. Department has many employees, so that's why I'm going with what? Set of employees. So employees is a variable of type set. So we are going with the object-oriented world now. Second, here you see, employee has a department. Yes or no? So we are going with has a relation. So this is what we talk in object-oriented world. And here in object-oriented world we talk with references. So that's why I'll have the reference of the, in department we'll have the reference of the set object, and here we'll keep the reference of department object. Has a relationship. Very simple. So now it is very easy now. If department has complete information about what now? Employee, and employee also has information about which department he is working for. Clear? So this is how we design the entities. Fine. And if you see now, see department, the cardinality will understand. One department has many employees. Okay. But one employee have what? One department. But we have to see from this side. Cardinality always goes from this side. One to many means one department is having many employees. We see cardinality like that only always. Yeah. So fine. That is done. So we understood association here. Association means what? Department has an employee. Employee has a department. See, department has a employees. Department has employees means that's why I'm having set. Similarly, employee has department means I'm having department here. So we are having has an association relationship here, association mapping. Then cardinality is what? One to many. Department has many employees means one department has many employees. We understood that. Now we have to understand the terminology bidirectional. Bidirectional means what? Here in this entity, if I load my department, I can get all the employees. And if I load my employee, I can get this corresponding department. Bidirectional. So that is why these entities are called as what? Bidirectional. Very simple concept. So they are bidirectional entities. Clear? So you can means anything you want. Means if I give the department ID, you can access all the employees there. And if I give the employee ID, you can access to which department is working for. That this is the concept. Let us see the code. You don't have to worry. But this is the concept now. And now how will you do this? It's very simple. You have to do mapping now. The only thing what you have to understand is the mapping of this particular set and this department. These two properties. What we do? Set of employees and department. We'll straight away map it to only one column now, called as DPT ID. That's the foreign key. This DPT ID will be mapped with employees and as well as department. If you do this mapping to this particular column, it becomes bidirectional. So only one thing which is coming out extra here is, you have seen one to many. One to many, what it will do? You got the set and you will map it to this particular column. You know how to do many to one also. You know how to do many to one also. So many to one is this department, and obviously many to one is always mapped with what? The foreign key in child table. That's it. Do the combination of both. So one extra tag you will need now. For yesterday's example or last class example, all you need is what? In the employee.hbm.xml file, you need one tag called as many to one. That's it. Otherwise, in department.hbm.xml file remains same. There what will you do? You'll use one to many tag. Here you'll use one to many tag. Here you'll use many to one tag. That's the tag you'll use. Here you'll use, for mapping you'll use one to many. One to many you'll use. And here what will you use? Many to one tag. That's it. But remember, one to many is a child tag of set. So you have to use it under set itself. That's all. If you do this much mapping, you're finished with what? Bidirectional. So these are bidirectional entities now. So, and you can fetch the values using any entity. Means if I use the department, I'll get all the employees. If I use the employee, I can get all this, all to his particular department now. So fine. So this is about what? Association mapping, one to many, bidirectional. That example means the department and employee, now we made it as bidirectional. Now we'll come to this example, association mapping many to one, bidirectional. We have seen this example also. What was the example? Many students are staying in one particular address. So that is the example we have taken, correct? So see the tables now. Many students are staying in the address means, so this is the child table and this is the parent table, correct? So here, see in the address, there are three columns. In the address table, there are three columns: address ID, city, and zip code. And in the student table, you are having three columns: SID, SName, and address ID. So in this table, address table, AID is the primary key. Here, in student table, SID is the primary key. Now, student is going to have what? Address ID, one more column. So this column is a foreign key now, and it references the parent table. That is address. So this is the design of the table. Fine. Now I'll give a requirement to use. So you understood the design of the table, and see this again. In Bangalore, okay, how many people are staying in Bangalore hostel? Ravi, Kumar, Amod. 3 people are staying. Similarly in Mumbai, how many people are staying? Mina and Girish. That clearly shows that many students are staying in one address. So again here the data is stored. Now I'll give you one scenario now here also. If I enter the SID, you can get his address. Yes or no? You can get his address to his staying in, means if I enter 1, student ID 1, means Ravi is in Bangalore. You can give that message. Means Ravi is the student and is staying in Bangalore. Supposingly I give the ID as 4, so you will tell what now? Next. He is Vinay and is staying in Mumbai. So given the student ID, you can find to which address he is staying. Now other thing now, ulta I'll go. What? If I give the address ID, I want all the students to be displayed now. Same scenario I'm giving, means scenario is changing in the project, but tables are same. So what I'll do now, given the address ID, what I should do now? In address ID number 1, how many students are staying? You should tell all the students now. Who is your view? So address ID, in address ID 1, that is Bangalore. You can give a message. Bangalore, how many people are staying now? Ravi, Kumar, Amog. So fine, you will display this, but you have to write the code now. What is the code you have to write? You have to connect to the database, collect all the values from the database into T or entity again. From these two tables, you have to collect it into the T or entity, bring that entity to the view layer and display it now. So this is how you have to do it now. So let us understand how you are going to design the entity here. Okay, very simple. Again, so this is a relational world. So in the object oriented world, we talk about what? Like this, we say student has an address has a student. Like this we tell. So that's why we go do what? Association mapping. Okay. Then the next thing, many to one. That's the cardinality. Many students are staying in one address. Fine. Then we know direction now. Direction means the idea is very simple now. If I have the student, if I load the student, I want his address also. As well as if I load the address, I want all the students staying in that particular address also. So that is bidirectional I want now. So let us see how you design the entities now. Very simple. So there are 3 properties here: SID, SName, and SID, SName, and address. So SID and SName are mapped to these 2 particular columns now. Then next, in address entity, AID, city, and zip code are mapped to AID, city, and zip code columns. Those 2 are clear. But again, this address property and this set, both are mapped, going to be mapped to AID only one column. So the one column will be mapped to both the properties. Like this we do. Understood? So here I'll be using what? Many to one tag now. Same, it is many to one tag, but here I'll use what? One to many tag. So in the student.hbm.xml file, here I'll use what? Many to one tag. Here I'll use many to one tag. And here I'll use what? One to many tag. That's it. Again, you understand? One to many is a child tag of set. That's it, same concept. But it's only the view from which side you are seeing now. Okay. If you see from the student, it becomes many to one. If you see from the address, it becomes one to many. Bidirectional. Understood? So that's the cardinality. So very simple concept. So only we are to understand this, what we have to do is just add, to do this, we have to just add one extra property or an extra mapping you have to do. So one single property and one extra tag if you add, unidirection becomes what? Bidirectional. Just by adding one property and one tag, okay, becomes what? Makes a unidirection to a bidirection. But it depends, okay, which tag and which tag means it will depend. Whether it is one to many tag or many to one tag will depend on cardinality. If it is a one to many, you'll use the one to many tag that side and many to one tag this side. But if it is many to one, what will you do? You'll use many to one here and one to many this side. That's it. It depends on the cardinality what you are using. So and there be all both the tags will be mapped to one particular column now. Which one? The foreign key column. So if you get this idea, now it's all about output now. Both the properties will be mapped to the foreign key column now. That's all. Okay. So the same tags almost all will be using for doing bidirectional. So unidirectional will be converted to bidirectional. Fine, this is done now. So in this example, one last thing what we have to cover is one attribute called as inverse. We understood the concept. One last attribute we have to cover called as inverse. So inverse is an attribute of set tag. Inverse is an attribute of set tag. Very important this one, and very frequently asked in interviews also. What is inverse attribute of set tag? So this attribute is generally used when you are doing one to many or many to one bidirection. So attribute is first point is it's a what is inverse is equal to true, means first is what is inverse. Inverse is the attribute of set tag. Then next point, it is this attribute is used with set tag when we are doing one to many or many to one bidirection mapping. Fine. Now what does this do? See, inverse is equal to true. Just understand. See, both the properties are mapped to one column, no? But who is the actual owner of this column? That is very important. Understood? Inverse is equal to true when I say here. So you are telling the opposite side, inverse. Inverse means what? Opposite. Opposite is equal to true means the opposite side is the owner of this particular column. Means the persistent operation for this column is the responsibility of whom now? Employee entity. When you are doing the persistent operation now, so that operation means when you save or update, do whatever it is, the responsibility of this column is taken care by employee entity. Inverse is equal to true. Understood? So it is the that's what you mean by inverse is equal to true. Giving the responsibility to the child entity. We are giving the responsibility to the child entity means we are making the child entity as the owner of that particular column. That's it. So almost all the concept you have understood now. There's nothing much here, but only thing is what you have to understand finally. One to many bidirectional as well as many to one bidirectional, both are same only. There's hardly any difference between both of them, and this is extensively used in projects. So I'll only show you the output. So first I'll go with association mapping one to many bidirectional. I'll go with this example. So then after I show you that example, then I'll go to association mapping many to one bidirectional. Clear? Yeah, so these are the 4 examples I'll be covering today. 11, 12, 13, 14. So what is in the 11th example? You can see association mapping, one to many, bidirectional XML. So first we'll see with XML, the same example, then we'll go with annotation. Then the 13th example is what? Many to one bidirectional XML. 14th example is association many to one bidirectional annotation. So these are the examples what you have to cover now. So one by one we'll start seeing. Yeah, first we are going with one to many. So one department has what? Many employees. So you know this. We'll have one property of type, three properties. One department ID, one dname, and one set of employees. Clear? This is how the department entity is there. Then the next one is employee. In employee, what we are doing? We are adding one property of type department. Right, segregators. So that's it now. Clear? So these are the two entities. Now you have to understand how is the mapping done here. Clear? See this. First I'll open department. One to many I'll open. Department is one to many now. Carefully see here. Class name, department. It is mapped with what? Department table. ID name, department ID. Type is it okay, but the department ID, the property, is mapped with department ID column. The next dname property is mapped with dname column. You know this. We are doing what? One to many. But one to many is a child tag of what? Set. Set name is equal to employees. So employees is what actually? Property. This is mapped with what? Employee table. Cascade means what cascading effect you want for which operation. You specify. Save or update, whatever it is. Last class I covered cascade. Inverse is equal to true. Means I'm making what? The opposite side as the owner of that column. Who is opposite side means who? Obviously. Opposite of department is who? Employee. So that will become the owner of the foreign key column now. That's it. That's the only attribute what you have to understand now. Key, then this one column name is equal to department ID, you know this. So this is mapped, employees is mapped with department ID column, and one to many we are saying that's it. So this makes what? One to many direction. So you are doing one to many cardinality now. A unidirection it is. This is unidirection. But the same way, if I add in employee.hbm.xml one more tag, it becomes what now? Bidirection. That's it. What is the tag we are writing? See this. This is the main one. Many to one. So department is what? Property. Property in what? Employee entity. Department is a property in employee entity. It is mapped with department ID. That's it. These other two properties you know. EMP ID is mapped with EMP column. E-name is mapped with E-name column. Email is mapped with email column. So this one. So if you just add one thing now, one to many unidirection, one tag if you add became what? Last class we had written only that much. If you add one property on this tag, it becomes bidirection. That's it. Clear? So this is how you do the mapping. So fine. So you understood how to use the tags. One important point you write about what is inverse is equal to true. Very, very important. We cover it off and then I show you the example. What is inverse is equal to true in Hibernate? Very important question. Inverse is an attribute of set tag in Hibernate. It is generally used in one to many or /output, many to one bidirectional mapping. Inverse is equal to true means the child entity is the owner of the relationship between the two entities, and the child entity should take care of persistent operation with the foreign key column in the child table, because both the properties are mapped with that particular column now. But whose responsibility is to take to do the persistent operation now? Both of them inside the record means problems will happen. So that's the reason we'll tell inverse is equal to true. When you say that, now Hibernate what it will do? It will use the owner of that particular column to do the persistent operation. But who is the owner now? Opposite side. Opposite side is nothing but the child entity. Very simple. Yeah? So that's the main thing about one to many bidirectional. Inverse is equal to true. Fine. Yes. So we saw the entities, we saw the mapping file. So once you see the mapping file and you know in the configuration file, you have to write your configuration file. In this configuration file, what you will be doing? Everything same, only you have to mention the location of your mapping files. So that also done. So lastly, we have to execute the program. But to execute the program, what you have to do? Create the tables now. So I'll create the tables and I'll run this code now. Client code I'll show you after creating the tables. So yes, we are going to work with what? MySQL only. I'll go to the test user. Done. So yes. So the tables scripts have been provided to you in the same project, tables.sql. You can open that. I'll copy all the queries. I'll paste it here. So all the queries will get executed now. Okay. So that's it. Your tables are ready now. So select star from, which is the first table, department. Fine, there are no records. Select star from employee. Fine, no records. So perfect. Tables ready, entity ready, mapping done. Everything is done now. Only we have to see the client code now. The client code, yes, it is there in demo.java. See this. Very interesting here and very simple also. We are creating one department. Correct? Department object I created called as IT, and that is done. Now I'll create an employee. Employee emp1 is equal to new employee. Employee1 dot set name Tom, and I'll give the ID. But now see, we are associating the department with the employee. There's one extra thing you have to do in bidirectional. What you have to do? The department has to be associated with the employee, not to which department? IT department. Same way, second employee you'll create and you'll set the name and his email, but you are associating the same department to what? Employee 2 also. Associate means you have to initialize that instance variable. There's an instance variable called as what? Set department in employee entity. See there? So you have to initialize this now. So that's what we are doing. Set department and I'll give the department value. So that's what we are doing here. So we are initializing it, set department, and this department will be giving it. Fine. Similarly for which one? Employee 2. Similarly for what? Employee 3. So 3 employees who are working for that particular department. So we have finished associating department with employee. Okay. After doing that, then all the employees I'll add it into the set. They are in the set. But now we have to do what? Associate employees also with what? Department. We associated department with employee. Here we are associating employees with department. It's very simple concept of Java. What you are doing in Java, what we do? I'm having an instance variable in this class also. I'm having an instance variable in that class also. So you have to initialize both the instance variables. That's all you are doing. You are initializing the instance variable of department also. This one we are initializing. At the same time, this is a Java world, understood? And in the employee we are initializing department. There are 2 instance variables, initialize them by calling setter methods. Okay, so that's it. So that's what you mean by associating. Done? So once that is done, you are ready for what? Doing your CRUD operations now. Means, you write your Hibernate code now. From the util, you get your session factory. From the session factory, I'll get my session, I'll get the transaction, and I'll begin the transaction. Just say session.save department. Now the records will be inserted into parent also as well as child also. But one thing remember now, when you are inserting the record into the child table, the responsibility is taken care by the child entity, because we are told inverse is equal to true. That's it. And it will be inserted now. So very simple concept. So just I have to show you the output now. So right, so let's run the program now. So the records have been inserted. We'll go and check. So in employee table also records have been inserted. Department table also records have been inserted. Clear? So that is fine now. So saving is done. Next, the important thing is we have to understand the direction now. So let's see, very interesting. See, I will do the read operation now. Now it becomes important. So department can access employee. Yes, because it has a relationship. See, I load the department now. Session.load. We are seeing the direction now. I showed you how to do the insert operation. Understood? Now we are seeing how to do the read operation. See this? I'll load session.load department.class, fine, and I'll get the department. ID name I'll get, but using the department I can get all the employees. D.get employees return type is what? Set of all employees. So you use generics here, and I'll use the enhanced for loop, and I'll iterate and get the details of all the employees working for that particular department. That's it. So we'll run this code now. So we are doing the read operation now, and you can clearly understand. See here, all the I gave the ID as 1 IT department, and all the records have been displayed here. Fine. Are you clear this code now? So this is how you do the means the read operation, and a very important point is what? Important point in this example, this concept is what? Department can access employee. That is okay, fine. Then next, see, employee can also get what? His address. That is very interesting here. Session.load employee means I am giving the employee as what? 2. Employee 2 is working for which department I want. Fine. I can get his ID, I can get his e-name, I can get the email. But look, I can get his department also. He's working for which department as well as name also. Employee department ID is name is whatever department is working for. Yeah. So we'll see this output now. Yes, employee ID given was 2, his name is John, is working for the ID department 1, and it's the IT department. Simple. So this is what is bidirectional. And you can see what support is Hibernate is giving you now for working with what? The database. Brilliant support it's giving you. Correct. You compare it with JDBC now. So we are not writing the complicated queries. I mean all the things are done by the Hibernate itself. We just go on doing what? Only one thing. Mapping the properties of the entity with the table. That's all we are doing. That's the brilliant feature of this thing. Even when you work with JDBC, entities have to be designed, but it is the duty of the developer to transfer the value from entity to database or database to entity in JDBC and all. But here what's happening? It is the duty of the Hibernate now to transfer the values from entity to database and to retrieve from database to entity. What a brilliant support we are getting now. So it is because of this powerful feature Hibernate is so powerful in the popular also in the market. So all will be done implicitly. All you have to do is what? Mapping. Okay. So if you do the mapping just in XML file or with annotations, we have seen XML, and you'll get this extensive support. Clear this concept now? So we have seen what? Example, one-to-many association mapping. One-to-many association mapping. Why? Because there has a relationship. Then cardinality is one-to-many. Direction is bidirectional. Understood? And with XML. Same concept we'll see with annotation now. That's it. Annotation doesn't change much. Only thing is we'll not have what? The XML file, mapping file. You can see how it is now. There's no HBM file now. Department.hbm file is not there, as well as employee.hbm file is not there. Only we'll use annotations. That's it. And the most important annotation you know now, we are going to use is what here? One-to-many. One department has many employees. So 1 to many. It is mapped by department. Cascade is equal to whatever cascading effect you want to give this. That's it. This one annotation on in department. And one more annotation you have to add in what? Employee. That's it. Many to one. Here you use many to one. That side you used 1 to many. Here you use many to one. One extra annotation use to the mapping. Add join column. Name is equal to department ID. That's it. So it's so simple working with annotations. Clear? Rest all is same. You know how to do the mapping. So if you want, I show you the output of this also. Client code remains the same. There is no change. What is the client code? We are creating the department object. We are creating one employee, associating the department with that employee. One more employee I will create. Associate that department with again this employee also. Again one more employee. Associate the IT department with employee. Then I will add all the 3 employees into set. And this set of employees I will associate with the department. Then I will just call what? Save method. Write a Hibernate flow in code and call save. Hibernate will directly transfer all the values from the entity into the database. Brilliant it is. Such a good support you are getting in Hibernate now. So yes. So again what we will do? We will create the tables. Again the tables are given here. Tables.sql. Open it. You can copy the script. So again I will run the queries. The tables, old tables were dropped, new ones are created. See now, select star from department. No records, select star from no records. So fine. So in demo now, we saw the demo and we are going to save the employees and the department. Done, inserted. Now select star from employee 3 records, select star from department 1 record. That's it. Only thing what we did with annotation. Same concept. And if you are interested, I showed you how to do the read operation. If you want, you can do what? I showed you how to do the save operation. You can do the read operation. And while reading, again you have to decide what you want. See here, if I load my department, same thing. I can get all the employees. So I'll show you this code now. I'm loading which department? 1, and I can get all the employees. So all the employees working for department number 1. But the concept is what? Department can access employee. Okay. Then the next one. You are seeing bidirectional. Employee can access department because it is bidirectional. So employee department ID is by department name is. That's it. So we are going with employee ID 2 is Tom and is working for IT department. That's very simple concept. Clear? So what is that we saw in this example? Association mapping. Okay. One to many cardinality and direction is bidirection. That's the concept, but with annotation. And I believe you should have got the idea by now for many to one also. That is what? Many students are staying in one address. So let us see, just I'll show you the code. You can see this. First we have to give preference to student because we are going with the many to one cardinality. So many student. So SID, SNAME, address. Fine. Are staying in what? One address. So you'll have set of students here. That's it. Same. Hardly any difference between what? One to many bidirection and many to one bidirection. So this is done. You know how to do the mapping now. So first I'll go with student. In student what tag you'll be using? Many to one. Understood? In student you'll use many to one type. Now in address what you'll use? One to many. But remember, one to many is a child tag of set. That one thing you should remember. Again I am telling cascade is equal to all, inverse is equal to true. Simple, over. Mapping done. So again what? Create the student objects. So I understood this particular thing now. So what we should do? Again configuration file. What you'll do? Mention the location of your mapping file. That's it. Last thing what remains is your client code now. Same thing. Address 1 is equal to, I'm creating the address object, creating the first student, associating the address with a particular student. Same thing, same concept now. Again one more student, Girish is associated with what? Bangalore. Then Amol is associated with Bangalore. Like this, create your students, associate them with that Bangalore address object. Understood? Means address 1. Finally you put all the students into set. Now associate all the students with the address. You are initializing the properties of both the entity, because we are working with what? Object oriented world. So we'll do it. Then I'll just say save. That's it. Say save. Now again the records will be inserted in address table also, as well as student table also. That's it. So let's see this. So you have to create again what? Tables for this. So the address and the student tab will have been created. So no records in student, no records in address. Fine. So only what we have to see is now what? Execute the client code. Yes, just I'll uncomment this. Yes, done. So select star from address, 1 record. Select star from student, 3 records. But this is actually many to one. Correct? Huh? Fine. So now anyway, we understood how to insert. Now we'll see the direction. So I showed you how to do the save operation. Next we'll see how to do the read operation. In read operation it becomes important. What? Direction. So address can get student now. Means if I give the address, I can get all the students now. Set of students. See, I am giving the student address as 1. I can get the address information, plus I can get what? All the students also staying at that particular address. Very simple concept. As you can see, in address ID 1 Bangalore, pin code is 560010. These 3 students are staying. Next, we understood that. Okay, but student can get address because it is bidirectional. Both can get each. That's it. Say this run as Java application. Fine. I give the student ID now, and I can get all his 2 Vinay, and is staying in Bangalore, whatever it is. Okay. So this is the idea. Okay. So these student names, you just change it off. I made it as Vinay Amor. You can make it as what? What I have given in the table while creating Ravi Kumar. You do it. That's it. I'll understand the same thing. Clear? This also will work, but what I am trying to say is in the diagram what I have given, that I wrote it again. Fine. This is done. So we have seen what now? Many to one, bidirection, XML. We have to see it with what now? Annotations. Same thing. Now you should tell me now. What you will tell? No mapping file. Correct? Huh? So we'll have entities. for those corresponding tables. Fine. So the student I'll show you first. In student, what annotation you use? Many to one. Join column you'll use. That's it. Two annotations we use. Mapping done. In address, what you'll use? One to many. That's it. Two attributes use. Mapping over. Yes, sir. So entity is ready. Mapping ready. Now configuration file. So in configuration file, you have to mention the location of what? The entities. That you'll do. Done. Then next is what? Create the table and execute your client code. Same thing. So again, what you do? The script is here only in this example. So tables are ready. Then next, we have to run the client code. In the client code, yes, we are having the address object I am creating, Bangalore and this one. Then here I will change it of what? Ravi and Kumar. Fine. So Bangalore, one address object I have created. Then I have created one student object. We are associating the address with the student now. Similarly, I have created one more student and associating the address with the student. Same concept, everything. Again, I have created the third student, associating address with the student. Then I will have one set where I put all the students and I associate students with the address. Finally, we will write the Hibernate client code. This is the Hibernate client code. From the session factory, you get the session, get your transaction, begin the transaction, and just say what? Session.save. That's it. Yeah. So now the records will be inserted. Directly you can check. Select star from address. Sorry. Double S and one value is there. One record is there. Select star from. One more is student. Done. Kumar, Amog and Ravi have been inserted. So we have done the same concept with what? Annotations. So saving is done. So once you do that, next if you want you can do read operation also. That is same now. You try it out. Okay. Means address can get what? Student, because it is bidirectional. Okay. Address can get student. I load the address and I can get all the students staying at that particular address. Sorry, here we have to see the output now. You can see I given the address ID as 1 and these are the 3 people staying at that particular address. Lastly, we have to see what? Using the, I can access the student information also. Sorry, if I use student, I can get the address also. It's bidirectional. You get the point now. So it's very simple. This is address. It is bidirectional. Done. So very simple. So just you have to understand now the mapping how you do. So see, when you are writing a project using JDBC also, almost all concepts remain same. What you have to create your entities, you have to create the tables, all that is going to happen. Okay, you have to when creating the entities, you will have what has a relationship. That also you'll have. I am talking about JDBC. Okay, so you'll have has a relationship, and again you will decide whether to make what unidirection, bidirectional. All that will be there even when you are working with JDBC. But the problem is filling the values from database to entity and entity to database. There we do explicitly, but here it is happening implicitly. That's all the headache remains same, but now only developer is relieved of or not bothered about doing the persistent operations and not bothered about writing the complicated SQL queries, what Hibernate says is, you be free about the persistent code, means do not bother too much about the persistent code, you just concentrate on your business logic. So all technologies tell you loud and clear only one thing, what? You learn advanced technologies, the benefit is you will be only focusing on business logic, and rest all things will be taken care by the technology itself. So this is one brilliant support what we are getting from the Hibernate. What? ORM, Object Relational Mapping. So powerful it is in Hibernate. So this is the main reason why Hibernate becomes so successful and popular in the market. So everything means, if you are using JDBC, all things will remain same. Designing, remember that, designing entity and then having relationship one to many or many to one, means having properties. Having properties means in employee you'll have what? Department, and in department you'll have employee. That is going to happen. Okay, all that will be there. But it is the duty of you to write the queries, retrieve the values, store it into entity. And likewise, if you want to say now, get the values from the entity and write the query and store it into the database. All that is going to happen. But here we are not writing all that. We are just doing what? Mapping. Either with XML or with annotations. So this is what is Hibernate, actual Hibernate. So like this, many ORM technologies are there. That is one more point you have to understand. Okay, IBATIS is there, JDO is there, Hibernate is there, many are there. But among all the ORM technologies, Hibernate is the most popular one and powerful one. Why you are only feeling it now? Okay, so almost all in other ORM technologies also concept is same, but their API will be different. What API? Here we are using session factory, session and all, no, but they will have their own set of classes and interfaces. But mapping concepts will remain almost all same, whichever ORM technology you are going to use. But we are learning ORM with Hibernate. Just give you an idea what is the market. Okay, so this is how it is done. So in some companies they work on Hibernate, in some companies they might work on IBATIS. You do not have to worry. You just have to understand whether they are using ORM or not. If they are using ORM, now it's all about designing entities and it's about mapping with the respective columns. It's going to be as simple. Done? Okay, that's it for the day.